Hi everyone, we are continuing our progression through Unit 1 notes. I apologize for the delay. We've been having some issues with the document cameras at the Fort Worth campus, and so I'm now converting to an iPad, and hopefully this will work out all right. It will improve. I need to get my Apple Pen is coming in. So we ended here last time, and I will just say that I will be skipping this graphing from a verbal description because A will kind of vary in the responses, and B, you'll see from the key that I urge you to look at ways to get a more accurate graph. But if we were to poll a room of people based on this description, there would be different graphs that people produced, and there are many right answers here. And so this is more of kind of a critical thinking activity. And so I'm going to go ahead and go to basic functions. This is a really nice graph that I would suggest, a piece of paper, I should say, that I suggest you perhaps consider printing out or just having ready for studying purposes. These encompass the parent functions of the graphs that we will most often be referencing in this class. And they consist of all of these functions, and a lot of the times you'll hear me reference linear functions, which make a line, or quadratic functions, which make a parabola, cubic functions, and so on. And what we do in this class are not limited to these functions, but they are, again, some of the more, the ones that we'll see more often. And then the other thing that I wanted to mention was that it's also important to know that the parent functions mean they're the most original function. If we do nothing to this quadratic function, this is what it looks like. But over time, we'll see we can do things to these functions, and these things are transformations. We can move them left. We can move them right. Like we moved from here to here for this quadratic function. See how it kind of moved over a little bit and down a little bit. And so we'll talk more about that later on. You don't have to worry about that right now. What you do need to worry about right now is kind of starting to think about the domain and range and how to identify domain and range. And so I urge you here, I've kind of on the key, I've put all of the domain and range for all of these graphs. If you want some practice, please feel free to look at those. We are going to talk about domain and range a little bit more on the next page. I will tell you, we are going to go very deep into quadratic functions and linear functions, and so we're going to have a big deep dive. And really, we've already been talking about linear functions in this first unit. So for domain and range, domain are your x values, typically, the input, and y is your range are your y values, or the output. And a lot of the times when I tell people how to think about domain versus range, is domain is what is happening from left to right on a graph, this blue. And the range is what is happening from the bottom to the top, or the red in this graph. And so if I gave you a function, a lot of the times we can look at the picture. And remember, on your calculator, you have the capability of looking at a picture. You can put it into y equals, put the function, then you can go to second, no, that's table actually. You can look at the table though. Second graph will give you the table, or you can just go to graph, and that will give you the picture. And from the picture, we can get domain and range. So let's say I did all that. And let's say I put this, and maybe you want to try this, put this in your calculator and see if you get this. And so pause the video if you need to. But if I, let's say, got this, and I'm looking for domain and range, again, My domain, I want to look what is happening left to right. And when I say that, I mean what is the leftmost value. So if I look at this, I'm like, all right, nothing, 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 nothing. And then all of a sudden, my graph starts. Boom, right here. It starts at -2. And it touches all of these x values all the way until 2. And then again, there's nothing. So that is why the answer for my domain here is -2 to 2. And it includes the value -2. If it includes a value, we use parentheses. Or in some set notations, we use less than or equal to, greater than or equal to. Anytime it doesn't include the value, which is oftentimes notated by a circle, we use parentheses or greater than or equal to without the line. So I'm going to, let's do this. So this means included, it includes the dot when we use these. When it's not included, we use these parentheses and the inequality symbols without the line underneath. Okay, please pause if you need to write because I'm going to erase. And then for the range, again, domain, we go left to right. Range, we go bottom to top. So I'm like, okay, nothing is happening to the y's. And then all of a sudden, boom, my first y value is at 0, right? That's the y value. And I am touching all the y values all the way up to this point. That's the very top y value. So this graph touches all the y values from 0 to 2, which is why that is my range. So I'm looking at what the graph is touching from left to right for domain and bottom to top for range. Okay, so if I look here, my domain, again, my leftmost value to my rightmost value is 1 to 5. It does not include 1, so I'm going to do a parentheses, and it does include 5. My range is bottommost point to topmost point. So I'm going to do, let's see, what is that? 0 to 3. It includes 0, so that should be bracket, sorry. It includes 3. I encourage you to pause the video and try to do these other two. So my domain here is -4 to 4, includes -4, does not include 4. My range is 0 to 4. And it includes both of those. For this next one, my domain is -3 to, I don't know, keeps going forever and ever. So, and that is open dot, so -3 to infinity. When we do infinity, because it's an arrow and it keeps going forever and ever and ever, we actually use a parentheses with that too, because infinity is a concept, not a number. And then if I look at the bottom, it's like, well, this keeps going forever and ever and ever, so it's touching all the negative y values. So this actually starts at negative infinity, and it goes on forever and ever and ever up until 2. And that is open dot. All right. If you have a graph, an equation, you can put it in the graph. So I'm going to do this one. I encourage you to do this one. If I put this in my graph, I'm going to go to y equals in my calculator and put this function, square root of x plus 5. If you need help with that, please let me know. The square root button is right above the x squared button. You'll need to press second. And then this graph basically looks like this. And at that point, -5 is where the graph starts. So the domain here is from, and it includes it, -5 to infinity because of that arrow. Your graph on your calculator won't give you an arrow, but it'll just go off screen, and that will give you enough information to know that that basically indicates that it's going on forever and ever and ever. And my range, the range starts at 0. Oh no, sorry. The range starts at 0, right? There's nothing, 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 nothing. And then all of a sudden it starts at 0 and it goes on forever. When it says, thank you, when it says that goes on forever, that's basically infinity. I'm going to let you do this one, put it in your calculator, and feel free to check the key. This is, again, kind of a critical thinking activity. This puts in a lot of information that we've talked about. It kind of brings it all together. So I urge you to look at the key for this one. You might not be able to answer these questions until we do this. Just a heads up. But this is kind of a check your knowledge point. If you do have any questions over this, though, please let me know. Okay. Increasing and decreasing in local min-and-maxes. So you'll notice that when it's increasing, it's when the y's are going up. And when it's decreasing, it's when the y's are going down. And when a change happens between an increase and decrease, or decrease and increase, that point is called a max or a min. And so we can identify those points on a graph. And so if I look at this graph, if memory serves, again, put this in y equals. And I believe, actually, believe it looks something like, actually, it is like this. If my memory serves me correctly, I'm hoping that it does. Again, I've done this a few times. So put it in y equals, graph it, and I've done this with my other classes. I don't have my key right in front of me, so I apologize if this is inaccurate. I'm hoping that it is not. Okay, so we're looking at when it's increasing, decreasing, min and max. I did this with a student the other day, and they told me that it was easier when I first identified the min and max. So let's do that first. The max is when it looks like a mountain, which is right here. So there is a max at 0, 2. And there is a minimum at 2, -2. And that is when it changes from increasing to decreasing. So I'm going to do increasing in green. So let's do yellow. So we increased, then we went to that max point, and we decreased. And from that max point, we increased again. From that minimum point, I'm sorry. So the yellows is when it's increasing. When we talk about increasing or decreasing, we talk about what the y value is doing. And so it's increasing from that arrow, which is negative infinity, all the way to 0, 2, or the y value is 2. Then the brown, we're decreasing from 2 to -2. But then we increase again. And we increase from 2 to infinity. All right, let's talk about a few things. Why did I use parentheses and not brackets? Because there are a lot of repeated values. We talk about 2 and a lot, right? -2 and all sorts of things. It's because at those points, it's changing from increasing to decreasing. If it's changing at that point, it's not doing both. It's not both increasing and decreasing. It's doing neither. It's plateauing and it's changing. So we don't use brackets because we can't include those points. We have to use parentheses. And then if you have two intervals that are increasing or decreasing, you have to write them both. And then you write a U symbol, which means union. It basically means and. It's saying this and this is happening. All right, I'm going to talk about piecewise functions on my next video.